Welcome to part 2 of Competency 19. In this video, we will work with effective instruction. Number 1, which solution process would be best for solving the following system? A, substitution, B, elimination, C, matrices, that's row echelon form, which is REF. I would say best to use REF, but whatever your choice is. And then D, none of these above. Well, it's pretty Captain Obvious if you look at your X column. Okay, matrices would not probably be the best in this situation, and especially not REF. Like I said, I would use reduced row echelon form, but that's my preference. However, I would use B. I think at this point, using B, elimination would be the best, because then you could just subtract the second row. It would be a lot easier to do that. So this would give us, if you subtract that out, that would create your zero pair. And then this would be a plus, this would be a minus. So this would give me 7y equals 14. And then I could just divide both sides by 7. And that's going to give me my y equals 2. And then we just substitute that back into maybe preferably the first one. So that's probably the best way to work with the students. Show them the easy way out, the lazy man's way, if they have to do it by hand. So definitely elimination for this one. And you've got to remember that this particular calculator isn't going to give you that matrices. Okay, we've got tables, we have a lot of great features, but we don't have that matrices feature here, which generally the purpose of a simple system like this is to teach them how to tackle it by hand before we go into the matrices. Okay, let's look at number 2. Right? What would be the best strategy? The best strategy shows students how to factor the following expression. Okay, now this one is going to take some thought. Okay, for me, there were two ways to think of this. First, you could write it out. You've got this square here. So you could deal with that exponent first and then deal with the inner exponent. But then, on the other hand, you could leave that and deal with the inner and then go outward. But let's see what our options are. A, apply the exponential rule twice. Actually, the inner expression here, that's going to be an exponential rule. Okay, that's going to be the perfect square rule. Yeah, perfect square, not least squares. Remember, that's a whole other topic. Least squares, think about what your least squares is. That's not going to be part of what we're doing. Okay, go back up to A. I kind of skipped my process there. Okay, it says apply exponents twice. No, the inner part, it's not the exponent that you need to look at. So, no. B says apply the exponent rule to the outside. Since the expression is inside cannot be factored. Well, remember I said I would start with the exponent on the outside, but here's the deal. The inside can be factored, so B is just an incorrect statement. Let's go to C. Apply perfect squares in the parentheses, then the exponent rule. Yeah, sure. I mean, you could do it the other way around, but if you look at the options they gave us, C's the best and only option that we can go with. Okay. Remember, least squares, that implies least squares regression in my thought. It's perfect square because if you look at the inner expression, that would be this. You have x squared, okay, but that can also be 2 squared, right? So this would tell me that in that parentheses in the middle, that I would actually have this. I would have x minus 2 and x plus. 2, which is my perfect square. Okay. All right. So that's how they're saying to proceed, how to tackle that. Gonna have to agree with that. All right, let's go to number 3. Number 3, how would you deal with students that want to only use mental math to solve the following equation? X plus 3 equals 12, instead of showing steps. Well, if you think about it, the reason we begin with a simple equation such as this to show them the algebraic process is so they can handle it, and then you move on to more complex things. Well, let's look at what our options are. A, provide the student with more advanced equations. Well, I don't think that's the ticket because you haven't shown them that yet. So you really can't throw something at them that they don't see. Okay. So I wouldn't choose A because that skips a teaching element. So let's see B. Change the equation to the following. Well, that is definitely not going to help. They still could use mental math, so that's not going to get your point across. Let's see C. Refuse to accept assignments with no student work. Well, yeah, you need to demand that they show student work, but refusing it doesn't help them understand why they're doing it in the first place. So that isn't really going to, you know, entice the student to do what you ask. So let's look at D. Help the student understand the goal of the task, which is to isolate the variable x on one side of the equation. That's usually what I say. I tell them the name of the game is to get x alone. And then from there, I say, if you don't play the game correctly, then you don't get credit for playing or something like that. So you just have to explain to them they have to show that they can play the game. So D would be what best choice. That's exactly what I would say. All right, let's go to number 4. Let's see here. Okay. While solving the Pythagorean theorem, some students are having difficulty relating the sides of the right triangle to the formula. All right, I'm going to jot that out really quick down here. Okay, we're going to have a right triangle. And I don't know about you guys, but I was taught A is the smaller one, B is the mid-sized one, and of course, C is always the hypotenuse. Okay, and then that would make this my right angle. Okay. Which strategy would be best to use to help the student with their struggle? Okay, it's all about what strategy. So A, show the student an example of the corresponding numbers. Okay, I'm not going to go for that one. I just don't see how that could help. Okay. I mean, I could have put in a 3, 4, 5 triangle, but I don't see how that's going to help just labeling it. Okay, let's look at what B says. Use a diagram with a right triangle with legs A, B, C, A and B labeled as well as C. Okay, I have that. As well as C labeled as the hypotenuse. Okay. Then demonstrate a solution with the values that correspond with each side, such as a 3, 3, 4, 5. So we were on the right track, or rather, my brain went straight to it because it's just something that I would always do. So we have 3, 4, 5. And if you remember from other videos, a 3, 4, 5 triangle is your smallest primitive right triangle. And if you don't know that vocabulary, primitive right triangle, look that up. Wikipedia has a great list of them and a very good explanation. These are the ones with whole numbers. Okay, when you calculate, you would get, for example, your first one would be a 3, 4, 5. Okay, and of course, you'd have multiples of that. You could have a 6, 8, 10. Of course, that would make sense. All right, so I kind of like B, but let's keep reading. C, use 3 different colors of tiles to demonstrate a Pythagorean triple with a diagram that has sides that have a a color that corresponds to the color of of the tiles. Okay, yes, but that would be what you began with. You wouldn't be at this juncture that, how they say they're having trouble with the sides and the formula. This would be after you did an activity like that. So that activity isn't going to help you with your conundrum right now. What it's going to do is, be an aid for those students who just had trouble getting started. So I don't think that's the best solution right now, the best answer, the best thing to do. Okay, so let's look at D. Instruct the students to draw a right triangle and label the given values. What they mean by that is whatever the formula has for value or the equation given, put that in, but that's not going to help. Put the numbers that they were given on a diagram, kind of like what I have here. The problem is they're having trouble labeling it themselves. I labeled it here. The difference is if the educator labels it to show them, to demonstrate, and then works them through it, that's different than saying, "Oh, the student has to do it." Well, they're already confused. It states in the problem that they're having trouble. So telling them to do something they're having trouble with isn't going to be an answer. Okay. I would go with B then. This is you're using a diagram and you have it already labeled, and then you demonstrate with the labels in specific values. That I agree with. Okay. All right, this is the last video in not the last video, the last question in this video. And once again, I want to thank everyone who watches, subscribes, and likes and shares. And kudos to everyone who has reported passing their test. You guys are really bright. And I appreciate, the nice words saying that we helped you, that these videos have helped. Okay. And again, happy testing, everybody.